Okay, looking at rate of change, we're going back to kind of grade 9 here. But rate of change, now we talked about it in the last note, rate of change is always equal to the rise over the run, the change in y over the change in x, or y2 minus y1, x2 minus x1. There's a bunch of different ways to look at it. So you've got your formulas up here. Okay, but if I just gave you a point like A, and A was, well, let's just call it x1, y1. Okay, just some point A, and we'll call this some point B, x2, y2. Okay, so the way we're looking at this is we're actually trying to make a triangle. We're doing rise over run. We're making a right angle triangle. Okay, now you can make this triangle, but a lot of people get it wrong because they do run over rise then. So I always go up first, then over. So rise over run. Okay, so if we look at this, we've got our y values, y2 minus y1. Got our x values, x2 minus x1. It's going to give us what we need, okay? We can subtract them. This here is your change, that's x2 minus x1. This, or the distance, sorry, over here, and the distance up here is really what we're looking at, not at the bottom there. That's y2 minus y1. Okay, and we've done rate of change a bunch. When looking at a linear graph, we use your rate of change or your slope. When looking at a nonlinear graph, we're always looking at the average rate of change. Okay, so if the graph is not linear, we can't consider the rate of change because it's not constant. Rate of change shows us a constant value. Okay, so if we're identifying rates of change on a table, so if we look at a table, the rate of change is 0 when the first differences are 0. So this is going to be a horizontal line. So what we're talking about here is, I'm just going to do a very simple example. So if we had x is 1, 2, 3, and y is 2, 2, 2, our first differences are over here. Our first differences are 0. Okay. If it's constant, the first differences are equal. So again, if we had x is 1, 2, 3, and y was 2, 4, 6, our first differences here, we're looking at the x's are going up the same values, the y's are going up by by any value, but as long as the x's have the same differences between them, we can always check the first differences of the y. They're going up by 2, it's a straight line. Okay, and then finally a curve, the x values would not be, so I'm showing you this kind of on the side there. 1, 2, that's a terrible one, 3. This would be like 1, 4, 9 or something like that. Okay, those are not linear numbers. We have a difference of 3, then we have a difference of 5. Okay. So in the table, the rate of change is calculated by subtracting consecutive y values, the first differences, and dividing by the x values. Okay, so dividing by x. I'm going to show you what I mean in a second. On a graph, the rate of change is just used by the slope. So if we were finding the slope from a table of values, the only reason you need to know this is if the x's aren't going up by ones. So like this example, we've got 2, 4, 6. If the y's went up by, I don't know, 4, 8, 12. Okay, so what we're going to do is we're going to look at those values. This is 4. This is 4. We know it's linear. Okay, so let's do this. 2. So our slope or our rate of change, they're the same thing, is going to be equal to, we just have to pick two values. We're going to pick those. So it's going to be 4 divided by 2, which is just 2. Okay, or 2 over 1. It doesn't matter how you write that. Here's some questions that go with this.